Ransford, over to you.
All right. Welcome, everyone. My name is Ransford Hyman. I am a on-device machine learning engineer manager here at Adobe in the Adobe Sensei organization. And I want to just give you a good overview of what is on-device machine learning at Adobe. So just a brief background about myself. I have a bachelor's in mathematics, PhD in computer science. I started my career out at Intel, where I did various different jobs working in architecture validation, then transitioned, did that for like 5.5 years, then moved over into the deep learning space because this was around the time when deep learning and data science was a sexy thing to do. So I started to pursue my career in that area and transition within Intel into deep learning software engineer. That took me to Santa Clara, to the Bay Area. And while I was in that role, I got into management for a couple of years within this deep learning project, working on a lot between that hardware software interface within the deep learning space, because I did a lot of floating point validation in my previous job and some compiler works. Then I moved into Adobe for 2 years, and here I was doing tech lead for on-device machine learning. And on-device machine learning is a fairly new, even now, it's still a very new area, a new domain within the machine learning ecosystem. But I came in, started as a tech lead, and then quickly moved over back into management because I enjoy the mentorship and enjoying growing people's careers and, just watching them do great things, together in collaboration. What is and why on-device machine learning? So typically when you look at the machine learning pipeline that's been going for a long transition of the field, many of the models are being trained in the cloud. It's a lot. There's a lot of resources in the cloud, and you just have a lot more, just less constraints. You have a lot of compute, you have a lot of disk space, a lot of memory. And a lot of these models that you're training, they require those resources because they are being trained over, number of days, sometimes number of weeks, depending on how large these models. So there's traditionally in the machine learning domain, there's been a lot of focus on deploying these models on compute, in areas that's other than the cloud, in the cloud domain. But with on-device machine learning, we focus on things that are anything that's not the cloud. So if you think about your personal computer, like how does a model run, on a desktop machine, or how does a model run on a mobile phone, and how does a model run, say, even on the edge device? Think about things like a sensor that you may have in a manufacturing facility. So all of these are what we consider either on-device machine learning or edge computing and edge ML. But why would you want to do on-device ML? So there's a number of reasons that one may want to do this. And from Adobe's, in any product team that you may work in, there's a good level of responsiveness. If my data is locally on a device, and I need to send that data to the cloud and have it be in compute, and then there's a turnaround time there. There's a latency that comes with that round trip. But with the on-device, you can actually run you can run your ML model locally on your device and not have that round trip to the network. And that also gives a benefit of having that user experience being very similar if I am connected to the network versus if I'm in offline mode. So say if you're on a hiking trip and you want to sort of do the same, utilize the same feature, but you don't have a really good signal, you could be in airplane mode and still have the same user experience for your client, for your customer, whether they're out in the hiking, in the wilderness, or whether they're in a busy city trying to use your product in the same time. So there's that responsiveness, and there's also that user experience where I can go many different places and still have my product work have the same experience in different regions. Also, there's the privacy preserving perspective. So when you think about when you're thinking about running models on on device, you're running your data and everything stays locally. So there's not a lot of things where things have to leave the device, and you get you have that sort of privacy preserving enhancement because of that. And then there's just also cost savings. There's a lot of money that goes into training your network, but there's a lot more money that goes in when you deploy your network, because when you're in the model deployment, the amount of inference calls starts to get up in the billions, and that's a lot. That can be that can be a lot if you need to utilize cloud infrastructure to call those endpoints that have, that are utilized. There's also, there's not only just the clusters that come about, but then there's an amount of compute that, depending on if you're choosing like a big A100 or a P40 or a T40 or what have you. So, there's a lot of cost savings that you have because every time you're doing an inference call, it's just utilizing the energy cost that's on the person's device, whether it's desktop or whether a mobile phone. So what are some of the challenges when deploying within the on device? So just as I mentioned before, a lot of these models are developed with the cloud deployment in mind because you've trained your model there, you've utilized, you didn't really have to focus too much on the, what sort of, how much memory it's using, how much compute, how many GPUs are you using. You don't really have that constraint when you're in the cloud because you can always scale up and scale down accordingly. That's usually AWS problem or Azure's problem or Google Cloud Platform's problem. But with that, after you've trained your model and this model is fairly large, now you have to move to this much smaller form factor where in a desktop environment, you may have, in the desktop environment, you may have a couple of gigs of RAM and you may have a powerful GPU, but if you're going to a mobile device environment, you have even less, maybe not as much gigabytes because there's a lot of other applications that's running on there. And you must have a lot less compute because of the form factor. You can't put a big RTX on the GPU on a mobile phone. It'll look pretty weird if you had that hooked up to your head. So now you're dealing with limited compute resources, limited disk space, and limited power resources because as we all know, machine learning is very compute intensive. And if you're running off of there's a lot of energy source that comes with that computation. And you don't want to have your machine learning experience be a battery drain. So now we have to think about all those aspects and how do we actually, how do we mitigate for those sort of things. So some things that that occurs during that process is what we call deep learning optimization. And you may have a lot of those, if you're training your model, there's a lot of optimization tasks that you can do during training. You can have, mixed precision. There's, a nice little library from NVIDIA. Then you have like distributed training, where's data parallelism, model parallelism, and things of that nature. But when you're going into the optimization for on device, there's there's a lot of tasks that goes into, doing that as well. And overall, a lot of it is really trying to compress. There's one portion is compressing that, network so that it can fit on in the memory space or the disk space of that device. And then you also want to quantize and reduce the, the size so that it can run efficiently on respective hardwares. So there's things like model pruning. So a lot, when you're training your neural network, there are a lot of connections that are not, they're not contributing a lot to the accuracy and the functional correctness of your model. So there's there's a technique where you can randomly clip, prune the edges between these neural networks at a certain, maybe like 75%, like randomly choose 75% of these edges and reduce it. And what happens is it makes your neural network very sparse. And once it is very sparse, that means it doesn't need a lot to actually store in memory, it's stored in storage because it's just a lot of zeros. So but the thing there is that you also need to have a hardware that can actually run in a sparse environment. So if you ever seen the capability of like be able to allocate a sparse tensor and be able to do sparse execution, those are things that usually are correlated to a model that's been pruned. Then there's also model quantization. So quantization is the concept of going from a lot of times when you're training your model, you're probably training with float 32 numerics. And what happens is there's been a lot of push into actually being able to deploy on integer 8 or even just float, 16-bit float. So 16-bit float is a lot easier to get to, but going from float 32 to 8-bit integers is a little bit more work, but it has shown to actually, maintain accuracy to a certain degree, but you get so much out of the performance and out of the space that you need to actually store the model, because you're going from a 32-bit, which is 4 megabytes, to just an 8-bit format, which is just a single byte. So that's a 75% reduction that you get just by doing model quantization, if you're able to quantize the full network. And then there's other aspects of how can I actually have a smaller architecture from the start, which is what neural architecture cert is actually doing, where you're trying to find the specific model architecture that can be optimal for running on mobile devices. So that's another technique. And the other is also knowledge distillation. Suppose I train my model with this very large model that can run in the cloud. Now I can use a teacher-student model where I can distill that knowledge onto a much smaller model that has a much smaller form factor, but still maintains the accuracy. So these are some of the techniques that are being utilized to optimize the model so that you can actually run it on these devices. So some of the deep learning hardware that is, that I sort of interact with, or, I come into contact because I work with desktop and mobile models. So I am always following the trends of what's NVIDIA releasing and what's Qualcomm releasing and what's Apple releasing. So these are some of the devices that you can see, like the RTX 3090. That's a really powerful external GPU that some of our clients may have. Suppose that they're working with like Premiere Pro, they need something that is really very performance intensive or can work with graphics really well. So some of them may have those on board. But as a platform and as a machine, as Adobe, we can't guarantee that everyone's going to have a 3090. So we have to make sure that how do we deploy these models so that we can have a very good user experience, even if you're not having these, some of these very high tech or high end, devices. So but those are some of the devices that we encounter. As you see, there's a Qualcomm, Qualcomm chips are in a lot of the mobile devices, especially on Android. So they're at least in the US. But as Adobe, we're an international company, so we have to also keep track of what are some of the big what are the hardwares that have been released in different regions. So for instance, like in Europe, there's like, if you have a Samsung Galaxy here in the US, it's most likely going to have a Qualcomm chip. But if you have a Samsung Galaxy phone in Europe, it's going to have the Exynos chip, because that was some of the ones that they released, which is a Samsung chip that was provided, and so forth. If you go into the Asian region, you might also see Exynos chips or different type of MediaTek chips as well. So there's different sort of different types of hardware that we become familiar with, whether it's like A15, as you see there, and also the M1 that just recently got announced by Apple last year. So there's a lot of on-device ML that you have to take into context, because now you're starting to see that they actually have dedicated hardware that is geared towards machine learning acceleration. So neural engine for Apple. Qualcomm has the Hexagon chip. Google has like this is more of an edge TPU, which is more for like doing things on the edge, like Coral. But yeah, so within my job, I have to, I like to keep track of what is the latest hardware and how we can sort of maximize and utilize, the capabilities of the things that they provide. As much knowledge as we know, that's given externally. And then there's the on-device machine learning frameworks. So a lot of machine learning practitioners are very, comfortable in PyTorch, TensorFlow. That's, their mainly tools of choice. But when you need to go into the on-device realm, there's a whole set of different inference frameworks that one has to utilize. So TensorFlow TensorFlow has TF Lite. PyTorch has PyTorch Mobile. A more open source representation is Onyx, ONNX. And there's Onyx Runtime that's being maintained by Microsoft, but it's it's also it's used a lot in on-device machine learning. And then Apple has their CoreML framework. So some of these, and WinML, Windows has WinML framework. So some of these are actually packaged within the phones themselves, like CoreML right now, all iPhones come with CoreML embedded, as well as Mac OSs. On TensorFlow, it's currently not packaged with it, but PyTorch Mobile as well. So you may also, as Adobe, we also have to look at what sort of costs do we incur by packaging some of these frameworks, because there's some overhead that comes with that as well. So yes, and just to talk about some of the AI at Adobe. So this here is and this is also running on device. This is what they call neural filters. This was a feature that was debuted at Max last year. And you can see here, this is where you can actually, it's using this is like a sort of a generative sort of feature as a GAN model. And you can see where you're having a slider where you can actually change the different features as far as like the facial age, smile. You can do things like colorize photos and all those sort of techniques there. Then you have things like on the left, you can see there's select subject, where you have a photo and you want to find out what is the main subject within this photo, and how can you segment out, so that I can make edits within Photoshop. So this is a AI powered technique where it is able to identify what is the main subject, and in this case, it will be the dog. And on the right, you'll see is the what we call auto reframe. And suppose you were doing a actual video that was at a 4:3 ratio, but you want to like upload this to Instagram on a mobile phone. So this is something where it can actually capture the doing the auto reframe. And Bill, he's going to actually do a demo that can go into this a little bit further. So stay tuned for that. And now we have Adobe Scan on the left side, where you can see this is where you're doing taking a actual picture and being able to do document, utilizing AI so that you can convert that document into something that can be highlighted, something like a PDF. So this is what they call document classification, where you can take a picture and it goes from that document into like a actual, where you can edit and copy and paste if you wanted to make any edit or share the content. And then on the right, you can see Photoshop this is Photoshop Camera, where you can apply different style transfers to a photo to give you different type of different sort of styles that you may want to utilize. So that's also utilizing AI on device. And then here we have something that is in Photoshop Elements. It's called moving photos, where you may take a photo and you can actually sort of give it a sort of like Ken Burns effect, where it's actually moving. And this is something also that's being done on device, utilizing on device machine learning. But then there's also the research aspects of, just AI. And the portion on the left is not so much of, not so much say on device, but it is other ways where we're also doing artificial intelligence, where you're trying to look into whether a image has been modified or not. And in the era of deep fakes or what have you, you can see that Adobe is taking a stance, in a position to make sure that we are doing our due diligence to be able to identify, content that's been modified from that perspective. And then there's on the right is a GAN being compressed to run on a Jetson, and that's some on-device ML, and that's been done in research, where you take a model like CycleGAN and speed, and you can see at the top, it's something that was running, at 58, 12.1 frames per second, and you can see once it gets compressed, how much faster it runs, and how much smoother things run. So those are ways where you can see the benefits of on-device ML. So yeah, I've been in this role definitely more than 9 months. As far as a machine learning engineer, I was in that role for like say 9 months, and then I've been doing being a manager for another say almost a year and a half. So a lot of my job is mainly on focused on deploying Adobe AI technology running on PC and mobile form factors. I have to work with a lot of the clients, a lot of product teams to help drive the expertise, drive that mission. So that's mainly a lot of my job. But overall, I wanted to sort of leave you with some lessons learned throughout my career. And some of those things is continuous learning is essential. I definitely, I'm a proponent of being a lifelong learner. I didn't start out in the AI career. I started out actually in VLSI, which is like low level transistor, that's my research. So just continues that learning, that lifelong learning, having that mindset really helps as you're matriculating throughout your career. Taking a driver's seat in your career, it's definitely when you become an employee, it's definitely good for you to work with your manager, but you don't want to leave it up to your manager to, always, guide the way, the direction you want to go. So being very proactive and being transparent is like, what is it that you want to do, and where you want to go, and sort of being, being the one to drive that side. So, along with your manager or your mentor. I always tell people to take risks early in their career because it helps you be able to evaluate risk better later. So early on in my career, I made a lot of mistakes. I would not tell you that there was this like really clean, trajectory to AI or what have you. I had a lot of places where I fell on my face, but it was good that I learned those things early, and took risks because I was able to evaluate risk now as a manager so that my direct reports won't have to fall on their face as much. They'll have to fall on their face sometimes though. And then also just being an effective communicator, but even a better listener. It's one thing about communicating your thoughts or what have you, but really sitting back and really listening and making sure that you're digesting what people are saying and being very receptive to that allows you to be able to communicate even more effectively. And I have this developing X factor in unlearning how to multitask. I used to try to always think that multitask was the thing to do. And I've changed on that mindset. So just being able to learn to focus on single task and giving your all in different, in spurts, in bursts. So here's some resources. I'll leave it at that. We'll be sharing the slides, but these are things that I found, throughout my my AI journey and things that I like to, follow. So I'll leave you with those resources and I'll hand it over to Bill.
Ransford, thank you so much. That was amazing. You're amazing. And it's an honor to work with you. It really is.
Thank you.
I'm going to ask everybody if they can see my slides okay. Is everyone looking at
that's good.
full screen mode? Okay, thank you, Ransford. So I'm going to give you a slightly different perspective. I am a machine learning product manager. My career path, I started as an attorney, actually. I gradually fell in love with computer science, decided I wanted to go back and study computer science. En route, I wound up at Mashable, where I was their data science fellow. And this was my first exposure to machine learning, specifically natural language processing. Wound up at Cornell, that's where I earned my computer science Master of Engineering. While we were students, me and another gentleman, we started playing with some ideas that we decided to pursue when we graduated as a startup. We ran that startup for about 2 years. That was called Uru. That was acquired by Adobe in 2018. I became a product manager at Adobe. I am now a senior product manager on a team called Applied Science and Machine Learning. You're going to hear a little bit more about it shortly. And I just want to mention, I do spend part of my time in Delaware, which is how I met the organizers of this event. So, maybe in the future, you'll catch me in person at another event. Okay, so here's my focus as a product manager at Adobe. We productize machine learning. I productize machine learning for all of Adobe's products. Our goal is always to start with a user goal or pain point. If you ever hear me talk, I'm really good about always making sure that is square one in your journey, is making sure that you're actually solving a pain point or helping a user achieve their goals. Machine learning is incredibly exciting, and sometimes there can be a temptation to take what you might call a tech-first approach to productization. But I really like to always try to start with the user goal or the user pain points, then investigate whether machine learning really helps users achieve that goal or solve that pain point. I used to have a professor at Cornell who would always remind us, don't use machine learning if there's something simpler that you can use. And I still believe that. You always want to take a hard look at whether machine learning makes sense and helps a user get closer to their goal or solve a pain point. And if it does, then you can develop and deploy a machine learning solution to achieve that goal or solve that pain point. My focus is on content, specifically my focus is on content understanding, transformation, and generation for all content domains. So that includes images, video, audio, documents, text, vector art, 3D models, textures, And I'm lucky enough to get to leverage many disciplines of machine learning in that, deep learning, computer vision, other sorts of computer vision outside of deep learning, natural language processing, lately generative adversarial networks. So it's all pretty exciting. Sorry, I'm having a slightly different issue, which is advancing. So let me just stop screen sharing for a second.
I think the first rule of a tech meetup is the tech will break at some point. So,
oh yeah, definitely. That's the rule of demos too, right?
yep.
Just 1 second, folks. I appreciate your patience. Okay. So here, am I screen sharing here? Okay, brilliant. Thank you. And thank you for your patience. So here's a little bit about the team I'm on. We are about 25 machine learning researcher engineers. And I use that term because everyone on the team is some blend of machine learning researcher and machine learning engineer. Someone who could do research, but can also deploy the machine learning model. As well as we also have data scientists and of course, product managers like myself. Like Ransford's team, we are part of Sensei, which is on one hand how Adobe's intelligent features are branded. We use the term Sensei, so you might have heard Ransford say that, and you might see that in product announcements and things like that. But Sensei also refers to Adobe's centralized machine learning effort. Both Ransford team and my team are part of that. And as I mentioned before, I get to work with all of Adobe's products, which is awesome. The way my process usually works is something like this. I go out, and we hear the goals and the pain points of all our different product teams and their users. We help them decide if machine learning makes sense as a solution. If so, we will often draft product requirements based on those user goals and user pain points, figuring out exactly what the classes look like for the model, what's an adequate level of accuracy that we're going to chase, what does the latency have to look like to support the use case? And then depending on whether a solution already exists in Adobe, we're either going to develop a data set that we can use to train and evaluate the model, or we're going to develop a data set that we can use to evaluate an existing model. Once we have a model that satisfies the requirements, and it can take some time to get there, we then deploy it either as a service or on device, which is where I get to team up with Ransford. We also, in parallel to that, we have to complete all necessary security, legal, and ethics reviews. And of course, we just do whatever it takes to deliver the machine learning to the product team and get it shipped. Sorry, folks, I'm hitting the wall again. I'm really sorry about all this. But the good news is I think I can just go off script for the rest of it. I did want to do a deep dive into one specific project of mine, and Ransford also alluded to it. So this is called Auto Reframe, and our starting point here was actually the following. The user pain point that we looked at here was that we wanted to try to solve or help with the time-consuming and manual process of cropping a video to a new aspect ratio. For example, you shoot a video in horizontal, you want to crop it to vertical. I think, as Ransford mentioned, maybe you're doing that for Snap or Instagram or something, but you want to keep the interesting parts of the video inside of the frame. So we unveiled this technology as a prototype at MAX 2018. MAX is Adobe's big conference for creators that happens every fall. It's really exciting. When it's been in person, something like 20,000 creators show up. And we have a really cool program actually that puts the spotlight on advanced technologies, including AI at Adobe. It's called Sneaks. And it's a showcase of in development research technologies at Adobe. If you go to YouTube and you type in Adobe Sneaks or Adobe Max Sneaks, you can see some of these sneaks, and it's a whole lot of fun. So we premiered this prototype at Max 2018. And here we are almost 3 years later, and we've actually been able to ship it to 4 products: Premiere Pro, Adobe Experience Manager, Premiere Rush, and then Photoshop Elements. So what I'm going to do now is I'm going to actually play you the video from 2018 Max. This is the sneak happening on stage, and this is going to show you even a little bit more about the technology. Okay, hopefully I'm about to show a video. Let me know if you don't see the video or if you don't hear the audio in the video. Hopefully I'm not getting any gray boxes either. Okay, no gray boxes, here we go. Fingers crossed. Let me know if you don't hear the audio.
Working with video can be a little difficult, even the most basic tasks. So I think this is a really cool tool. Nicola Win-Tin is here with me to tell you about Project Smooth Operator. Give him a warm welcome.
Smooth Operator. Smooth Operator.
Hi, everyone. How's everybody doing? Good. I'm super excited to be here. I'm also a little nervous, so bear with me. Anyways, I want to start by showing you something. It's an aerial shot of a car driving through the desert. It's a really beautiful shot, isn't it? Here's the thing, though. When I try to publish this to Instagram stories, this is what I get. The car comes into view and then immediately disappears. What's happening is that Instagram stories expects a vertical video, but we gave it a horizontal one, and so it kept the center, discarded the sides, and this is what we're left with. The car is only visible for a couple seconds before it vanishes. It's not that great. To make this right, I have to go into Premiere and manually adjust things using keyframes and all that stuff. But that's a lot of work. What if, instead, we could identify the action and just follow it? This is what Project Smooth Operator does. So I'm processing the same video here. And the bright part that you see that is currently shifting to the left with the car, it's our crop. It's what makes it to the final output. What's happening is that Sensei is analyzing the video to determine the most important regions to include in the final output. And once processing is done, this is the result. Thank you. The car stays in frame. The output is still vertical, but we preserved the original content of the video. All right, let me show you another example of turning a horizontal video into a vertical one. This is an action shot of a skier doing a backflip. It's really impressive, so we want to make sure we capture this properly. And now that processing is done, here's the result. It's nice, right?
Yeah.
It feels very natural, although under the hood, the crop is swaying left and right to really follow the skier and capture that backflip 180. All right. Now, we all have videos on our phones that might be cool enough to post if things were in view, but maybe not important enough that we would edit them in Premiere. This is a video of my coworker, Allison, playing with her dog in the park. Now, I want you to take a second here to really appreciate what Sensei is doing for you. This is a video with multiple important regions. The crop switches between Allison and the dog and performs this natural panning to include both in the final output. And so we don't miss out on any important moments like Allison throwing the frisbee or the dog catching the frisbee. All right, let me show you one more example. This one is more extreme. It's a skydiving video. It's a really fast-paced video with a lot of action, with multiple people weaving in and out of frame. The camera comes close and goes far again, and it even goes upside down several times. Again, Sensei identifies the salient regions and seamlessly shifts the crop to include and retain the most essential parts of the video. And after processing, this is what we get.
Yeah.
Thank you. The output, this time we did 1-to-1, so the output is square. And as you can see, we retain all the action in the video. With Project Smooth Operator, you can focus on jumping and not dying. We'll take care of making sure everyone makes it to the final video. Thank you.
Good stuff. Thank you, Nico.
All right. So that's it for me. Thank you.
Awesome. Thanks so much, Bill and Ransford. Just really, really appreciate both of your conversations and like really feel like they highlight such important issues in terms of how we can be effective machine learning engineers, thinking about product, thinking about problems, thinking about deployment, all super, super important. Definitely want to encourage people to drop some questions in the chat if you're interested in having us answer them, and I'll help curate some of those questions to pass them along to Bill and Ransford. But just to get us started thinking about this, I want to start a little bit talking about career first, and then we can jump into some of the tech after that as people get going. Ransford, you gave some really direct, great advice for people in terms of what they should be doing as they're thinking about early career. And one of the things people always talk about is continuous learning, and what that's so important in tech no matter what. I love that you mentioned 2-minute papers, great resource, highly recommend that. I'll give the shout out there. But can you talk a little bit more about what your practice looks like to make sure that you're continuously learning, continuously growing as a machine learning engineer?
Sure. A lot of it is watching 2-minute papers. That's one aspect. I do sort of have, I have for news feeds, I have a certain, a filter for AI, artificial intelligence, machine learning, deep learning as a catalog. So I may scroll through some of the, what things are coming out. I also so within Slack, this is something I got from, I've done it, we've worked, and what happens is I have Twitter bots set up on either specific companies or even specific main players, that's within the field. So when they release a tweet or what have you, it comes within the Slack channel. So I call it paper feed. So for all the different papers or stuff, that are coming out. And then there's one for say on-device feed. So if a specific on-device company has released things. So that's one way that I sort of keep abreast. I like having conversation with researchers because they're reading a lot of the papers. Occasionally I'll go to conferences, and if there's an important paper, I'll go back and read a few papers as well. So I do read research papers as well. But a lot of it is just a lot of the just having bantering sessions with people with Bill, having bantering sessions with Bill researchers, the ML practitioners, just sitting back and so what's going on in your space? What is the interesting things that are you working on? And just those bantering sessions, you sort of ask those inquisitive questions. So like I said, a lot of times when I'm usually setting up meetings with people, but I'm usually on the listening end, and then I may ask some inquisitive questions. And after you have a sort of multitude of that, you can start to put a little sort of trend on, oh, this is something that's really trending in this area. I might want to keep an eye out on it. Or this is something that so that's one thing. On the hardware side, it sort of comes naturally because I've followed the hardware space for quite some time. So I'll listen to a GTC or watch out for what's the net, a WWDC, and even the Google I/O. And I'll start with the keynotes to sort of hear what is on their mind and what are their positions. And you'll hear them, you'll start to hear things like on-device intelligence, on-device machine learning. So you're thinking, oh, they're really into that technology. So let me sort of drive a little bit deeper in. So that's me. I'm sort of like an information spaz, but I like to, have a few people around me as well that are information junkies, and we just share that information.
Love it.
Yeah.
That's awesome. I feel like curating what you're listening to and what you're ingesting just really helps simplify continuous learning process. I think we got a couple of questions that are super similar to each other for Bill, and really they come down to like specifically, so you talked about determining whether ML or AI would help solve the problem when you're talking with users. Could you talk about a time when that didn't happen and talk about how those conversations might go?
Without pinpointing, nothing specific comes to mind, but just one big bucket here is data is the lifeblood of machine learning, right? So I think one question or one of the sort of questions that helps you answer whether machine learning is going to make sense is, do we have data? If not, how are we going to get it? So I think that's a bucket, where we often, that kind of influences what actually makes sense and what doesn't, is what data is out there, and what are we going to have to do to clean it up and actually train the model on it.
Cool. Related question that popped up just as you were talking about that. So can you talk about some of the ways that you all think about generating training data sets? If that's possible, not too close to the secret sauce for you all.
Well, could I jump ahead and take one of the other questions?
100%, yeah.
Okay, because I think the second question I saw was, what are the differences between an ML engineer, an ML researcher, and a data scientist role at Adobe? That's a great question. And Adobe is a large company with a lot of teams doing machine learning, but I can speak to this with regard to our team, applied science and machine learning. So like I said before, most of the folks on our team are some combination of machine learning engineer, which I think of as someone who can actually deploy a machine learning model to production, stand it up as a service, help get it running on device. And then a machine learning engineer, machine learning researcher is more someone who can, tackle a problem from scratch and do what you would traditionally call research, right? So everyone on our team plays a little bit of both of those roles. I think some folks are more on the researcher side, some folks are more on the engineering side, but because we're an applied machine learning team, it really helps to have folks who are sort of savvy, at least, about both. And then data scientists on our team, this is going to be, obviously very different team to team. They tend to focus on assembling data sets, cleaning data sets, and evaluations. I don't know, Ransford, would you want to chime in on that particular question as well?
Yeah, I think you hit it right. And a lot of, say, machine learning engineer is more of taking machine learning models into production, like the productization around that, because there's a lot of different, there's when you train the model, and then there's even when you're evaluating it, but then there's, I wanted to deploy this into production where millions of people are going to interact with this. So there's, the evaluation sort of criteria becomes a lot, even more challenging, or, it's a lot more, you have to dive more deep into it. How you package the model, like how it gets packaged within the product. How do you encrypt the model if you want to have model security? All those sort of things come into place of, how you deliver the model, like when should this model stay in resident memory and when should it not? There's a lot of things that come into play that make sure that you have a good user experience, but also that you're not bloating the app, because if your machine learning model is the largest thing out of the whole thing, and you're adding like hundreds of megabytes to it, then no one's going to download your app. So you have to think about all those, all those criterias in regards to app size, how the user experience, evaluation criteria, all those things that come into play. And a lot of machine learning engineers play on that side. Machine learning researcher is usually probably more on the cutting edge. They're maybe doing more things on the model architecture side, and also trying things that may be a little bit more riskier. And once, there's a time when that sort of reward versus risk becomes really valuable, and it gets transferred over onto the product side. And then there's some effort that needs to be brought into that.
Got it. Ransford, question that I got on DM for you is, you mentioned directly, like, taking risks and you made some mistakes early in your career. Could you talk about one of those that you think would be like helpful for people here to hear in terms of
Sure.
what might be valuable for them? Yeah.
Yeah. I mean, there's many I can remember, but let's see. One that I can remember. Let's see, from a technical perspective. So when I first joined, within the industry, I was working on floating point validation within Intel. And if you know the history of Intel and floating point, there's a big thing that happened, which it cost the company $400 million to fix. And it was just a precision error within the division of float division bug. So the precision was off by like one bit in the mantissa, and they had to replace all the chips because of that precision. And it cost them $400 million. This was in the 90s. So you can imagine if you were to scale that up to now, it would be in the billions, of today's dollars. But so anytime, any sort of thing that happened, if I would like refactor code because the code was also written in the 90s. And I was like, oh my God. So it was, I was really trying to refactor it to where I can use later C++, sort of things. So I was really ambitious, I'm gonna change this. But the thing is that this was pre-silicon validation. So, and it was used, of course, floating point didn't change as much, but every chip within Intel has a floating point unit. So anytime you I did a refactor, and it was like a 1 precision off for one of the floating point instructions, and I was getting showstopper blockers. So there was the thing would be to okay, revert your code and then just get back to a state when it was working. But I was doubling down, no, I can fix this. I know where that error is. So just doubling down, yeah, I can do it. And it just caused the error to go for longer and longer. And these chips needed to tape out sometime, and it really caused a delay. So it caused a really big storm. And it was what I really should have just did instead of let my ego get into it was to just revert the code and then deal with it offline, but instead I was just yeah, I can fix this. Do a little push a fix, and yeah, I think I prolonged that issue for a month, and yeah,
Happens
people were mad. They were mad at me for that. So that was one I would say. It's just that just sort of there's a level of humility one should always have, in the sense of you should be confident in what you do, in your skill sets, but you should also have. I sometimes when if someone has a disagreement with in certain things, I do try to come from an outside perspective and say, okay, let's assume that I'm wrong, and try to go from that proof by contradiction, of whether I'm right or not. So I was okay, let's say I'm wrong. Okay, let's go through that, and then let's that's a math side. I'd be let's do proof by contradiction then, and see if it really holds up. And so that's that sort of process. That balance of being confident, but also having some humility and understanding that no matter how smart you are, you can still be wrong and you can still make mistakes.
Definitely. And I realize we've only got a couple minutes left here. So one, maybe two more questions that we can get through before we've got to wrap it up for the night. Really love this question from Chris, and this is actually true for me too. So both of you transitioned to the field. What are the guiding principles that you would give someone in the midst of reskilling into the ML field in general? And then how do you figure out where you want to be between engineer and researcher so that you can kind of plot a career course for yourself in terms of the experiences you need and the education that you need? Not a small question at all. I'll let either of you take a stab to start.
I could start in on that one, Ransford, and if you want to follow up. I think with regard to the first part of the question, I think just get started is the #1 advice, right? I mean, lucky for all of us, this is a field that is still pretty nascent, and there's certainly some veterans, but if you start now, then you're still really at the lead of the pack. So I think get started, and get started anywhere you can. That's always my first advice to people. I do think when it comes to how do you kind of strike this balance between engineer and researcher, I think it's always good to try to find a way to productionize something, right? Can you, other than just training a model, can you build an app around it and put that app in people's hands and see what they do with it and see if if the UI UX makes sense and if it's making the kind of predictions that they expect it to, and if it's not, then do a rev and try to get closer. So I think that sort of hands-on productizing ML experience is always totally awesome.
Definitely love that advice. Ransford, anything you want to add real briefly before we've got to drop off?
Sure. Yeah, I would just say, yeah, I agree with that. And I agree with everything that Bill said. From my perspective, I would always, what I learned from my experience is to try to find what's that least path of resistance, because I was trying to go from like a software engineer, hardcore software engineer, to like a data scientist. And for me, that was a really challenging sort of transition. But I went to the AI route because I already had software engineering there. And now it's just more so learning the skills to, utilize, say, my software engineer skills within the AI field. So trying to do that, trying to find a good like incremental, rather than going for the big moonshot, is always something to consider, as well as, when you are doing your learning, making sure it's project-based, because as you're working on a project, you get to understand some of those nuances and challenges. And when you're going for a company in a business, that's one thing that, companies want to know is how do you, there's the educational side of things, and when you're learning the theoretical side, but how do you deal with the actual practical productionized side? So if you have some experiences about the mistakes and learnings that you have and be able to speak about that, then that really shows that, okay, you really conceptually understand what it takes maybe to go from an idea to product.
Definitely. Great insights. And just Bill and Ransford, thanks so much for joining us tonight. I'm going to drop the link to Adobe Sensei in the chat for everyone. Definitely check out the team that they work on. Just some really great work. The videos you shared were amazing. And if you want to go back and look at some of those videos, we'll be sharing the recording of this on LinkedIn, on our social platforms. Please take a look at those. You can find that at Delaware Data Innovation Lab across the board. Thanks to everyone for asking some great questions. Apologies if we didn't quite get to it because of timing. But we look forward to having everyone back for our next event, which should be sometime in the late November, December range. We're still working on getting it up online. So one last round of applause for Bill and Ransford, and otherwise, have a good night, everybody. We'll see you soon.
Thanks, everybody.
Thanks, everyone.